Okay, looking now at question 2, it asks us to name the materials used in the plug and give the reason why. Now, this question actually is worth 2 marks, so this is a mistake. It should be worth 2 marks. So let's describe what they're made of. The pin is made of brass because it's a conductor, but it's also hard, which means it's difficult to change the shape of it so that it'll stay the right shape. And we won't be able to sort of bend the pins very easily. The outer casing is made of plastic. Why is it made of plastic? Well, because plastic is an insulator, so it'll protect us if we touch the outer case of the plug. Where's the fuse connected to? The fuse is always connected to the live. That way, if the fuse melts and breaks the circuit, the live wire is disconnected. If we had the fuse in the neutral, the live would still be connected. It says the wire acts as a resistor. What effect does a current have on the wire? It increases the temperature or heats it up. Anytime you have current flowing through a wire, it heats up that wire. Okay, calculation here. So we have a power of a washing machine, somewhere between 0.7 and 2 kilowatts, depending on what it's doing, right? So maybe if it's spinning or heating, it's going to be using 2 kilowatts. And if it's just kind of doing some like normal washing between the bits where it's going to use a lot of energy, it's only going to use 0.7. We need to find the maximum current, which means we need to use the maximum power, right? Like if we need the most current, we're going to need the most power. And then our mains electricity supply is 230 volts. So we write down what we know. We know that the power is 2 kilowatts. I'm going to convert that straight away to 2000 watts. We know the voltage is 230. And it asks us to find the current. Current is a question mark. Okay, so find the right equation. It's power equals current times voltage. We need to make I the subject, so we've got to move V to the other side. It's a times at the moment, so it's going to become a divide. So P divided by V equals I. That's going to equal 2000 over 230. And with my calculator, 2000 over 230, 8.7 amps. It doesn't ask me to give it to 2 significant figures, but it seems sensible. The numbers in the question, actually, a lot of them are to 1 significant figure, so you could even argue that this should be 9 amps, but I think 8.7 amps is suitable here. Okay, next question about a fault developing. What's going to happen that causes this? So, when the metal case becomes live, the earth wire is going to take away that energy. It's going to take away any charge that builds up on the surface and take it straight down to earth. So a large current, let's bullet point this, 2 marks, 2 bullet points. Large current flows from live to earth. And think about what that's going to do to the fuse. Well, the fuse is going to melt. Let's say the fuse in live wire melts. So that large current, that is going to melt the fuse. And that's how we do. Oh no, we've got one more part. Part D, new research shows, well, most people got this one right. Any idea of reducing chance of electric shock. If you said anything sensible there about electrical safety, you would have got the mark. And that's question 2 done.